on YouTube when we put up a little bit later. Okay, so good morning, everybody. Welcome to this 10 o'clock webinar, Reliable Modeling Techniques for Inventor. My name is Aldred Boyd. I'm an application engineer for Micrographics. And if you please feel free to email me after this presentation on my email address over there, if you do have any further questions. You'll see at the bottom of the team viewer, a sort of little bar tab over there. There is a chat box. So if you do want any questions, you can just put up over there. If you do think of anything while the presentation is going on, and then I'll just address it, after the presentation is done. Okay. Okay. So let's begin. Okay, just a little bit about myself. I'm an industry specialist for the Autodesk manufacturing products. So I've been, I work on things like AutoCAD. Inventor obviously is my forte. Plus, there's all the other manufacturing products that you do have: AutoCAD Mechanical, AutoCAD Plant, AutoCAD P&ID, Autodesk Vault, so the data management products that we do use as well, AutoCAD Electrical. I've got about just under 20 years of experience. So I've been doing this for quite a while. And I did start off like probably everyone else did with AutoCAD, and then obviously migrated to Inventor, where I've sort of gone along for the next couple of years. I am both AutoCAD and Inventor certified, so I've written my professional exams for that. And in turn, I'm also an Autodesk certified instructor. So I've done my exams for that as well. So if you do come for training, you are getting trained with myself. You are getting trained by an Autodesk certified instructor. And I've also presented both at Autodesk University Extensions Joburg and Cape Town as well, on things like tips and tricks in Inventor and iLogic, which you'll also find in Inventor. Okay. So question, have you ever had your Inventor model explode after making a change? And probably the answer to that for everyone is yes. We've all had it. You've been working on very nicely, and then you think, okay, I just need to change this feature or change the sketch. You change something and, oh, you get error messages, red flags everywhere. And now you need to go find out exactly why this thing is not working as you should be doing. Okay. So for that, I've just put up a little agenda just to try and mitigate some of those issues that you do get when you are, sort of modeling in Inventor. So things like learn how to take control of your relationships, your parametric relationships. Okay, so that is a given. You need to know, why is this doing it? So you take control, you get more predictable models out. Learn how to build complex parametric parts that are too robust to fail. Okay, so too robust to fail. Look, about 98, 99% of the time, this will happen. You will get those issues, where something that you could not have foreseen will go wrong. The model will explode, but let's learn how to try and build this thing as watertight as possible. Learn how to document your models. Okay, so now when I say document your models, not sort of your IDWs, your DWGs, your 2D drawings. This is, why did we create this model? Why did I put that sketch in there? Why did I put those parameters in there? Why did I create the feature that I did? Document your models so that either yourself or one of your team understands why this was done. And then we're just going to take away a best practice workflow that become an office standard. So out of all the information that I give you, you can sort of get an office standard so that everyone is on the same page when creating models. So it's very easy to navigate any pitfalls that might occur. Okay, so questions you might ask as well: why is parametric modeling so difficult? I mean, when we were working in AutoCAD, what happened? You'd create something, and it would be perfect. Yesterday your parametric model was fantastic. It was all good. It worked. Today you come and open your model and it's broken. Something's happened between yesterday and today. You haven't touched it. What happened? So these are just some of the things that happen to us on a day-to-day basis, and hopefully some of the stuff I say today will be able to help mitigate those issues that we see over there. Another question I also get asked is there a right or wrong way to create a part in Inventor? And the short answer is no. Everyone thinks differently, so they'll create parts differently. Someone who comes from maybe the manufacturing or the CAM side of things will think about, creating the entire stock model and then start chipping away, where others, who come from a drafting perspective might, build up different blocks. So you build up this cylinder, and then you join it to another cylinder, or you join it to a block, and that's how you do it. So you either additive or reductive sort of drafting or design work. And what we're going to do today is just kind of give some guidelines to create what we call a well-modeled part. So something that is predictive. If you change anything in the history model, then it's going to change the part according to the design intent that you were looking at. Okay, so things for criteria for a well-modeled part. Okay, so I take a look at two things. Firstly, the correct geometry. If you don't have the correct geometry, your correct dimensions, correct angles of the features that you're building, the correct sketches, then then you're not going to get the correct parts out at the end. So you're going to manufacture something, you're going to take it out to the real world, and it's going to be wrong. It's not going to fit somewhere. It's not going to sort of have the design intent or that you've given it. So you must have the correct geometry from the beginning. The second part or criteria for a well-modeled part is it must be easy to update. Now, this is not so easy because it's kind of, you have to plan for something like this, for something to update. Now, you want to create a part that, when I start this part, by the time I finish with this part, if I change any of these key values over here, it needs to update in the way that I expect it to update. So planning is essential in this. So easy to update means that when you create something, you're not going to get that there's now a problem, dimension to reference geometry that could not be resolved. You need to foresee things like that. Okay, so with your parametric modeling, which is what Inventor is, you have some pros and cons. Let's look at some of the pros and cons here. So the pros is it allows you to change your model very quickly and easily by changing maybe a few parameters. Now, I will go through parameters a little bit later. It's those, your D1, D0, D2 that you find when you're dimensioning a part or dimensioning a sketch or dimensioning a feature. And things that these are very useful for is like your library components. You can create a model like a bolt and nut or washer, and it needs to update accordingly. It must be M6, M10, M20. The lengths of the shaft needs to be maybe 10, 12, 15, 20. So you've got to if you're able to be able to change that very quickly, parametric modeling is great for that. If you've ever sort of modeled up in a product like AutoCAD, that is quite difficult. You can't just by changing a couple of values get those different lengths. You're going to have to create the bolt in AutoCAD, and then you're going to have to make a copy of it and then go and change the length. So now you've got two different bolts. Whereas within parametric modeling, all that criteria, all those values actually sit within inside one model, which you control through your parameters. Another thing it's quite good for is configuration. So I don't know if you guys have played around with iLogic before. Very, very powerful tools that does come with Inventor as well, where you're able to change a configuration of, say, for instance, this tire in the bottom right-hand corner over here. You've got 6 spokes over there for the wheel, and now, just by changing a parameter, you could have 8 or 4 or 2 if the design will allow you to. So yes, so with parametric modeling, you're able to do those two different kinds of modeling technique or modeling. You create those different models very, very easy by changing a few values. Okay. Now, some of the cons, and these aren't really cons, but more sort of concerns when it comes to parametric modeling, where you have to take a look and also think a little bit more about it. If you had to work in AutoCAD 3D, you work in 3 dimensions, your X, Y, and Z. But if you take a look at parametric modeling, you're actually working in 4 dimensions. And that 4th dimension is your change over time. So how is this model going to change over time? You take a look at, like a TV, for instance, you've got a 40-inch, a 55-inch, and a 60-inch. The length and the height needs to change. Maybe the components need to move inside the TV to, sort of to accommodate what's going on. And that moving of components, or that resizing of the parts, is that change over time, which can also be put down to design intent. So, what do you intend for this design to do? How is it going to act? Where a part's going to get placed in an assembly, and how wide or high is it actually going to be? So thought and planning must go into that design intent. It's not like AutoCAD where you can just sit down and just start drawing, or back in the days when you drew on a pen and paper, you can just start drawing. Oh, that's not right. Rub it out. Just redraw it. Yes, it gets a bit messy, but the initial design comes out at the end. Whereas in parametric modeling, you want it to be clean, efficient, easy, and the design intent from what you started off must be with what you end off with. Okay. Things can go wrong. Parametric modeling, as I said, if you don't think it out, things do go wrong. And some of those things are unintentional relationships. You might create something, for instance, let's take a look at your sketching. So you're sketching and you've got that automatic constraints that get put onto sketch elements. And, you might have quite a large sketch, and in the top right-hand corner, there's a line. You've drawn another line. It automatically makes that 90 degrees where maybe you didn't want it to. Now you carry on with the design and you come back and say, listen, right, that line's not right. I need to change the angle. And it can't, because it tells you that there's a perpendicular constraint on it. So there's unintentional relationships. You don't want to create those. Those might be created unintentionally. Editing a feature that breaks your part. So there's that whole exploded part that we've got over there in the model. Okay? Design intent is lost. If you don't keep your head about you and your wits about you, it might just be, time is running out. You start to panic. You start doing things that you aren't thinking about the end goal. And then when it comes to changing the part later on, because that design intent is lost, the model is not predictable. Valuable time is lost fixing models. So this is something that happens when we are under a bit of pressure, a bit of time. It's a Friday afternoon, and this model needs to go out because it's got to go to the supplier, or it's got to be checked by someone else. And instead of us, if something goes wrong, it'll take a long time to try and fix those problems. And what we do is we end up just fixing or remodeling the part from scratch. And that's what we don't want to do, because all that time lost is time, is money lost as well. So we want to kind of have the model as reliable as possible so that we don't have those time wastage moments. Yeah. So just once again, just to reiterate, in the past it was AutoCAD, and with AutoCAD, the quicker you drew, the more productive you seem to be, in the office. And but now with the present and the future, taking Inventor, a parametric modeling software package, requires a plan. And as with everything, plan something out very, very well. It's going to benefit you in the future. If you plan something, it might take a little bit longer in the short time. But when it comes to the end results and having to change it or having to get different products out of something that you've modeled with good planning, then, for instance, it will be much quicker to be able to change and get out results from that initial planning that you did get. Okay. Now, for reliable modeling techniques, there are three things that you kind of want for your models. You want editable, obvious, and reusable. Now, with your editable models, your model intent is captured. Okay, so what you thought about in the beginning and how it's going to change is going to be what you get out in the end result. And that is very, very important, because once again, it's that whole time between redrawing something and just reusing something. Obvious models. Now, document your design intent. So we'll see how we can document the design intent in the models. Okay, so if you're going to give this model to someone else in your team, they need to know, why did you do this? How did you do this? Why? What is this? Why is this feature here? And if why have you made these three parameters your key driving factors on how this whole model changes and conforms to the design intent? So, documenting your design is very, very important. And reusable models. Okay, we don't want to rebuild, from scratch. We want to reuse our models. So, by using editable, obvious, and reusable, you'll get a nice, reliable model out in the end. Okay, so why do we have reliable modeling techniques? Because you get complex and complicated parts. Okay, so with complex, you can see there's lots of features in there. That goes into that product, and you get complicated. So complicated, there's a bit of a different modeling technique you use that, which I'm not going to go into today. But because you've got surface modeling there's a different set of rules that come into play. So these are the two different kinds of models that you get. Okay. What makes a model complex? So is it one solid and a few features? Not really. That's not a very complex model. Is it creating parts that will not change? So something that maybe you get from a supplier? Not really. Maybe it's a complex model for the supplier because they've got to, sort of draw it up. But for you, you're using something that's not going to change. It's something that's static. It's a stock item, and for you, that's not complex. iParts, iAssemblies, and iLogic designs, that is complex because that has got lots of configurations, lots of thought into the relationships that you have in between, in your model. So that would be more of what a model of a complex model. Okay. So when you look at complex modeling, what are you going to find in it? Multiple sketches, multiple features, multiple bodies. So with bodies is multi-body or skeletal modeling. Multiple updates and a long history tree. So you can see over there, I've got, okay, there's only one solid body in here, but I've got some sketches. Now I've got a lot of, extrusions, ribs, fillets. Okay, so it does become quite complex because there's a lot of relationships between all of those different features that I actually have put into this part over here. Okay, so with relationships. Okay, one of the things that we must do when creating complex is understand and control the relationships that we put in there. When I'm drawing a sketch and say I'm drawing, I've got a feature, an extrusion, and I draw a sketch on top of that one face of the feature. Okay, so what's happening there? We are now creating a relationship between the new sketch that I've created plus the geometry that I've put it on. So maybe I've projected the edges. Maybe there's a hole going through that feature which I've projected a hole. So now we're creating a relationship for that. And we've got to be cognizant of that fact because if, for instance, we've got that hole disappears, we delete that hole for whatever reason, the design doesn't need it anymore. But is anything in that additional sketch that I've created attached or connected to that hole, that sketch that I've got? Maybe I've created another hole which is now referenced to that hole. I delete the first hole. Now we've lost that relationship to the second hole in that sketch. So we need to be careful of that. So, parameters, sketches, features, bodies, okay, that's all being a part and parts as well. But then also your constraints. And you can see how as we go through each level, I mean, there's 1, 2, 3, 4, 5, 6, 7 levels over there. There's more and more relationships that get built up which are reliant on other relationships. And if we don't control those relationships, we can find that the model might implode. So, please, control the relationships, understand what you're putting down. Okay, just to reiterate, if you do not understand your relationships, your model will not update in a predictable manner. Okay, and Inventor doesn't manage this. Inventor is just a program. We input what we want out. So the more you input, the more you get out, but you must understand what you're inputting. As I say, garbage in, garbage out. Okay, so just guidelines. Do not create unintended relationships. Keep your relationships to a minimum. If you don't have to go put a relationship in because or control everything from maybe one source, then that actually does make a big difference. Plan your relationship, have purpose for your relationships. Why are we doing this? Why are we putting this this 90 maybe a 90-degree dimension in when maybe you could use a perpendicular constraint? Or if you put both in, why are you doing that? Just keep it to a minimum, plan it, and have purpose. And relations must be obvious and easy to understand. And there's that whole obvious modeling again as well. If I'm going to give this to someone else on my team, it needs to be obvious to them. Or, if you're just working in a one-man team, and for instance, I come back 3 or 6 months later to this project that I've been doing, it's got to be obvious to myself. Because if it's not obvious to myself, then we've lost the point of, of this reliable modeling that we're trying to get. Because you don't want to go and grab a part 3 months down the line or a model or assembly where you now have to sort of go through the whole process of trying to understand your model. But if you documented it nicely and made it obvious, then it's going to be much easier to get back into it and be able to complete the changes that you want for the job or that the client's asked for. Okay, just an example of design intent with relationships. You've got this 60 by 60 by 8 mil plate, and the part's got a hole in the middle. Okay, now, if I update that part's dimensions, what's the hole going to do? Now, so I'm going to draw, say for instance, Inventor, you draw a square or a rectangle, you make it 60 by 60 and 8, and you just plonk the hole in the middle. There we go. You don't dimension it, you don't constrain it, nothing. If I now make it an 80 by 80 by 8 millimeter plate, that hole might stay in the middle, it might not stay in the middle. Because have you maybe constrained one of the end points of that plate to the center point so that it grows in a manner that you can predict? But then if it does do that, that hole is actually going to shift to the left or the right. It's going to be close to one of the sides and smack bang in the middle. And that's why with your design intent, I would have known, right, that hole has to be in the middle. So when I design it, I'm going to make a parameter or dimension that's going to be from the one side to the middle of the hole. It's going to be half of the, of this one of the 60s, and then the other side as well. Or you constrain it midpoint to midpoint of the two lines that you want it to be centered in. And that's the design intent we're talking about in the relationships. Whereas, make those relationships, document them and have purpose for what those relationships are. Okay. Now we've all had this. We get a part from someone else, and you have to kind of figure out what's going on here. So what Inventor does have, which you might not know, is a relationships manager. So if you go into your history tree and you right click on any of the features, you can see on the left hand side there, in the drop down menu or the right click menu, you'll see relationships. And it brings up the relationships dialog box over there. And you'll see there in the middle selected is my base extrusion. And I've got dependencies, top connector, hole one, top connector thread, mirror one, mirror three. And I've also got my requirements. So you've got your parents and your children. Now, the nice thing about this, it allows you to quickly go and find what those either parents or children are to see what's kind of going on to diagnose this, this part in the relationships. So you can either you can see the little arrow, you can click on that, or you can click on the little button to the right, which is actually to edit the feature. So you can very quickly go and just see exactly what's going wrong. Or, what the part is about. Okay, the next one is, if something goes wrong, what do we do? So the first thing that's going to probably happen is you try and change something, you don't understand the relationship, and an error message will pop up. Now, one thing I please must employ you to do is read the error message. The error message does tell us kind of what's going on. It might not drill down to exactly what's going on, but it'll kind of give you a focus on where to focus on how to solve this problem. So I do know I've get a lot of support that comes my way, and the sort of something's gone wrong, Aldred. Can you help me? Great. And just by reading the error message, 90% of the time it's telling you what to do. But I do understand that sometimes, you're on a deadline. Your mind is like, I just need to get this finished. Why has this error message come up? You don't actually read it. So just read the message to see if it is something that it does explain. If it doesn't explain, I mean, by all means, give a call. We are here to help out. Okay. First things, once you've identified where the problem is, take your end of parts and move it to below the affected area, so the extrusion or the sketch. And it most probably be in the sketch where the problem is happening. So move that end of part all the way up, and then fix the error. Okay, don't leave it to linger. Or if maybe it's got a little exclamation. It's still there, but it's still giving an error. Just fix the part. What you will probably find is that these errors do cascade. So, once you fix the one error, it will actually fix all the other errors below it. But once you fix that initial error, just move the end of part one down, one by one, make sure that everything is still there. It's still sort of working properly until you get to the bottom, and then you go. And then, we need to learn from our mistakes, take a note of what the error was, take a note of kind of what you did, to get to that point. And then, remember for next time. Just on the end of parts, a nice thing to do is if you do get parts from other people, or you on the internet and you can download. There was something called the Inventor World Cup a few years back. Where you had to model up something that the administrators gave you. You always find that 3 or 4 different people would get the right answer. But the way that they got there was different. So if you want to learn like sort of new ways to model up, because everyone does think differently, download people's models or get something and they just move the end of part up and you can see how they've created it. You'll always come up with new, better ideas or new ideas on how to improve your own modeling skills. Okay. So this is something that comes up quite a lot as well. Sketched versus placed features. What do you do? You've got dual tools available in both your sketch and your features, like fillet, chamfer, mirror, and pattern. Okay, so general rule is obviously keep your sketches simple and use features where you can. So if you can use a fillet, a chamfer, a mirror, or pattern in your feature instead of your sketch, use it in your feature. Okay, why? Okay, so I've said, here's the guideline, but why? Failure diagnosis. Okay, so most errors do occur in the sketch. So if you can keep your sketch as simple as possible, then you're going to sort of navigate away from those failures or those errors that occur in your model. Flexibility, okay. Just for if you look at alternatives and different configurations of a part, or how does it look like with a fillet versus a chamfer? Just getting to that feature is much quicker, or getting to that tool is much quicker going into your feature than with your sketch. Because remember, your sketch, when you create it, once you've created a feature on the sketch, it gets consumed, so it's kind of hidden, one level down. And if you want to go and identify where this is, instead of having to go through 10, 15, 20 different sketches, you'll just see over there, it's right, there's my pattern. Click on it, great, edit, change it, and there we go. Or suppress it because you want to look at a different alternative. Preserving design intent. Okay. If I have just draw out a circle in a sketch and extrude it as a cut, or if I actually create it as a whole feature, it's much easier to identify that hole over there. Because in my mind, I'm seeing that's a hole, but in my history browser, it says that it's an extrusion, and that can just just sort of muddy it up a bit. And then also downstream processes like your CAM and your finite element analysis. Okay, so I know when I'm doing FEA, finite element analysis, I don't need all those fillets. It's not going to make a difference, very much of a difference when it comes to actually doing my calculations, getting the end result from my finite or my FEA results. Okay, and for me to now go into every single sketch, if I put all my fillets in my sketch and have to go and delete it or suppress it or do whatever I need to do to change it, it is quite a nightmare. Whereas if I can just see it in my history browser, I can just go and suppress it very, very easily. Okay. So which are the easiest relationships for Inventor to calculate? Okay, so the ones that take the least amount of time, that's not going to give you sort of a lot of road bumps. Parametric relationships. Because Inventor is a software package that works on a computer basically does mathematical computations. It's very, very good at that. Parametric relationships, you go into your parameters and you put along a whole lot of equations, width, length divided by thickness. Inventor knows how to solve that really, really quickly. Okay? So if you can do that, do a lot of those relationships and move or manipulate, modify a part through the sketch, through your parameters, it goes a long way into increasing the speed and efficiency of your Inventor. The next one up is sketch to sketch. Okay, this is known as horizontal relationships. So as you see over here, at the bottom, you got your triangle and you got your construction line over there. And so we're looking at that sketch. And that's actually, as it resizes, it also then resizes the vertical sketch that we've got as well, the one where you've got the circle over there. So that kind of sketch, we're using projected geometry, and Inventor is also then able to sort of calculate those quite quickly. There's not a lot of sort of mud in the waters over there. The next one up is sketch to feature. Okay, so this can work very, very well, if you know the design intent and where you want to kind of go to, but just be careful of that as it does take longest. It's sort of the third longest one to do that. So how it works is you've got your initial sketch and you put a feature on that, and then you've got your second sketch on that feature, and then you've got another feature on that. So just be careful of that. There's more steps that Inventor needs to go and calculate through as it's building up this model that you got. And the most complicated one is feature to feature. So this is where things can go wrong the most, is when you got feature to feature. So yeah, and Inventor will take a long time to kind of calculate those type of computations that we've got over there. So those are the relationships, and from the shortest to the longest time it takes to calculate. Okay. Now this is something that a lot of people also ask me about, like or you start modeling because you're not thinking about what the orientation of your model is. You get to your assembly and all of a sudden things are upside down or back to front or left to right. So traditionally what we have is engineers draw components from the front, and let me just give you a brief history about this. We all come from AutoCAD or sort of a 2D background, where it's kind of like working with like your architects, where Z is up, so you can just see the little the picture at the bottom over there. So but engineers, when you're drawing in 2D, is kind of they draw components from the front where your Y is up or coming towards you. So what you need to do is just keep sort of in your mind exactly how this thing is orientated when you do start working. And you'll see there that you've got your origin work planes. I'm going to talk about that a little bit later, but rename your origin work plane so that you know exactly which plane to start working with and which is going to be the top part of your model. And this also comes down to the standards that you've got working or you've got in place in the office. Everyone needs to know, right, guys, when we start building something, we're going to start on this XY or YZ. But rename it. You can rename your origin work planes, as you will see a little bit later. Okay. But also, once again, with the orientation, if you think about if you work with AutoCAD or Revit users, Inventor Autodesk is bringing that whole Revit Inventor connection closer together, the bridge, so that we are able as engineers to be able to work with the architects and give them our models as well, so that it is in the right orientation. Because you don't want to get a model, bring it into another package, and it's sitting on its side. You want to kind of build it correctly from the beginning. Okay. And then, as I said, please look at your standard templates. If that quick standard templates you got, save it as standard.ipt, standard.iam, or standard.dwg or idw. Yeah. Okay, so just back to the origin planes. Work with origin planes. Work with your 000 points, because they can't be edited, they can't be deleted. Okay, so you can't move it. You're not going to find all of a sudden when you bring your parts into your assembly that now your origin is way off to the right or the left. So with the as I was saying, rename your origin planes. A very good practice, so that as you come in here, instead of seeing XY, YZ, or YX, you see their front, you see their top, you see their left. So that very, very quickly it just enforces and it forces guys to work on the correct plane, so that when you get someone else's model in your team, they are working the same way that you are. Their model's orientation is the same as you would have it. Okay. Then going on to parameters. So if you don't know what a parameter is, it's basically any value you put in for your sketches, your dimensions, how high a feature is, what's the taper dimension going to be. So those model parameters, you got two different parameters. You've got your model parameters and you've got your user parameters. Now, the model parameters get created automatically, okay? And as I said, they define a D0, D1, D2, and they're assigned to sketches or features. Problem with model parameters is that if you delete that feature, it deletes the model parameter as well. So you can't reuse it for something else. Okay, so you need to take note of that. So what we can do is we can create user parameters. And there are three different types: numerical, text, and Boolean. Text and Boolean is used mainly for your iLogic functionality. Okay. And we're going to work mainly with the numerical. And with the numerical, you can put all your equations in as well. So think about if you're doing some sheet metal, you might want to have two numerical user parameters that are on every single part that you've got. And those numerical parameters are maybe your length and your width, because that's, or the stock plate width and the stock plate width and depth. So now you've always got that there, and you can reuse that and start the design off at a sort of template level, so you don't have to go and create a whole lot of other stuff. Okay, just some parameter naming rules. Okay, they are case sensitive, so length in capital letters and small letters are different. It must start with a letter, but obviously it's alphanumerical, and it can't have any spaces, so you need an underscore or a colon to separate words for that. You do have some parameter names that are reserved for Inventor, and also keep it short but legible and provide comments. I know everyone's seen those comments on the end of it, and I mean, sort of people don't put comments in, but put comments in because you want to keep your parameter names short, and then your comments will elaborate on exactly what those parameter names are. Okay. Documenting your design intent. Okay, so great, you've built all this up. It changes predictably, but how did you do it? Why did you do it? So document your design intent. So let's take a look at how we can document some of how some of the design or documentation processes we have in Inventor for that. So once again, as I said, comments. On the right-hand side there, you can see comments. I mean, I don't know if any of you actually use the comments, but it's a great way to be able to elaborate on why I named this parameter, what I did, and what it does and what it controls. Did you know that you can rename your features? Okay. And this is fantastic because then it kind of leaves a breadcrumb trail, to guide you through the design. One thing, feature names must be unique, and also maybe create a suffix or a prefix with that as well. Why do I say rename this? Okay. For instance, just a little example. So, boss extrude, boss sketch, boss hole. Now, why am I, doing that boss? Because, I don't know if you know this, is that you've got search functionality in Inventor as well. So right at the top there, you can see there's a little magnifying glass. You click on that, you type in the keyword that you've got, that you've renamed a whole lot of stuff with, and it actually filters all of that out. So you will now see every single sketch and feature with the word boss in it. Okay, so that is actually very useful when you're going and actually interrogating a model that you've got. Yeah. Did you know you can show extended names? So these are automatic. Okay. Basically click on the little hamburger icon at the top there, display preferences, and show extended names. So it just gives you a bit more information on the feature that you are working with, so that you kind of get more info automatically, and you can actually get to the design, interrogating it a little bit quicker. The engineer's notebook. So this has been around for years and years and years and years. So anywhere you can just right click on any of the features, it says create note, and then it does a little snapshot of the of the part, and it puts your text note in there as well. So you can anytime go there, and maybe there's some information on the extrusion or the hole that you want, in addition to all the other comments that you've made, maybe in your parameters. And then this is also new, model-based annotation. General notes. Okay, so you add a screenshot with it. So sorry, it'll actually put in there. This is a new component, you can see over there, and it'll be visible at all times. Okay, so as you're moving around, it'll always have that note sitting in the top left-hand corner of your screen over there. One thing you want to do is when you're creating parts and you're going to be resizing them, it gets longer or shorter or higher. You want it to move in a predictable way. And for that, use your 0 point, your 0, 0, 0 point, your origin, and either constrain it to the bottom left-hand corner or the middle. So in the first picture there, you can see that it moves predictably to the right, down to the bottom right, and up. Whereas if I constrain the center of that rectangle to the origin, it will move to the left, right, up, down, and up to the Z-axis as well. Okay, just once again, it allows us to have that fixed datum, and the predictability. You really want that predictability when doing reliable modeling. Okay, and once again, just with that center point, just see where you want it to be before you start modeling. Once again, plan before you start modeling. But think, what do I want to do? How does this need to actually behave? Because you'll find that as if you just start all haphazardly, as you go along, it's come to a point where it's like, I actually didn't want it to do this. Now you've got to go back in your steps and actually find what point do I need to change it. And that might also disrupt a whole lot of other modeling that you've done as well. Okay. Layout sketches. So this is actually a nice way to control your model as well. Your layout sketches, create a sketch that kind of lays out exactly where everything's going to go. So, and as I said, one of the reasons, if anything's going to go wrong in your model, it's most likely the sketch. Okay. And when we started working in Inventor, we were taught one sketch per feature. Okay. But design intent is not captured or might not be captured with that one. Also, if you do sketches that are too complex, you might be difficult to diagnose when there are errors. Okay. So we got to kind of find a nice balance between the two, of having very simple sketches, one sketch per feature, with very complex shared sketches that you've got. Okay. So what can we do? We've got work planes, which we can put onto a layout sketch. And on those work planes, so you've got a layout sketch, and your work planes are connected to that sketch, and then you put additional sketches on that, and then you kind of run additional features on those work datums, there's work plane datums with your feature sketches on there. So by that way, we can actually control a little bit better, because if you think about it, if you start putting sketches on existing feature faces and something goes wrong with that feature face, it's going to destroy your sketch as well. So there's more involved when you start putting, as I said, features on features or sketches on features, which is those relationships we spoke about earlier. Okay, so just to reiterate again, it's like building a house of cards. If one card at the bottom, sort of goes down, everything's going to collapse. Or if it moves slightly, or if it gets modified, it's going to affect things that is sitting on it. Okay, so as I said there, base the sketch on a datum plane and link it to the bottom layout sketch over there, and this preserves your design intent. Okay, so it's kind of it's what we kind of call skeleton modeling. Everything kind of relates back to sort of one source of truth, which is quite nice when we are working. Okay, so this is something that I found which is quite nice. This is a little bit of a guideline on what to do. So when you're building up a part, kind of use these 5 different columns or the different ways of modeling to build up your part. So the first thing is you add to your model. So using things like extrude, revolve, thicken, rib, sweep, loft, and quill. So that's the first thing that you do when you're building up your component. Then you modify it using things like draft, shell, or thread. Okay, so that's the second part. Then remove, trim, holes, embosses, deleting faces. Only once you've done those 3, then you move on to your patterns, your mirror and your pattern. And then finally, you go into your chamfer and your fillet. And the rule for fillets is concave before convex and big before small. And by using those 2 rules, you'll find that your fillets shouldn't fail too many times. Just with that, I know that way back in the past, about 10 years ago-ish, if you had to put in too many fillets and even one of the fillets failed, you'd have to restart all over again and make sure that the fillet that you did not want to, the fillet that did fail, you have to make sure you don't select that. Now in Inventor, if you do select a whole lot and one fails, it'll tell you that this one has failed. Would you actually like to create the rest of the fillets? And it will create it for you like that. So we just, take a look at this sort of matrix over here, follow those rules, and you should get some quite reliable models out. Okay. Test. Please test your design. As you're going through, rather test early, and have to get to the end and all of a sudden something fails, and, because you didn't check something and a relationship between this feature and that feature, it doesn't work. You don't want to be sitting on a Friday afternoon at 6, 7, 8 o'clock trying to fix something because you've got a deadline. By testing early and, testing often, you flush any unpredictable behavior out your design. Okay. And then, it's much, as I said, it's much more difficult to correct something down the line than it is once you actually are, working on it early up in the design phase. Okay. And just, another thing that people do ask me is like, why do fillets and chamfers come last? Or, in that matrix, why do they come last? It's because they're consuming edges, and if something changes on that edge, it's more likely to fail. So rather do it right at the end, because it's like I said, it's not a good idea to do it earlier on in the design. Okay. I know that you can create multi-fillets with different radii in the fillets command, but try not to do it. Yes, it might make your feature, your history tree quite long, but when it comes to diagnosing problems, it helps that you can, if you know that this 3 mil fillet is giving a problem, you don't want it mixed up with another 5 mil, another 10 mil, sort of maybe convex instead of concave fillets. You've got one problem. There's one feature that you need to go to, and then take a look and then fix that right there, right then. If you do want to, have some complex fillets, there are the ruled fillets as well. So, just take a look at that, and you can create ruled fillets, especially when working with plastic parts and grills and things like that. Okay, so just something to help you with this. There's something called the Inventor Design Checker. This is available for, on the Autodesk App Store. It's available if you are on subscription. So if you're not on subscription, then you won't be able to see this. But it kind of, gives you some rules and sort of live feedback on what's happening. So if you can see at the top right-hand corner over there, you'll see there's those two gauges over there. And the one has got one red bar and the one's got three red bars. So obviously there's something going on over here, and I need to check it, with regards to the rules that I've set for myself whilst modeling. Okay, so this is one of the screenshots of the design checker. So in my modeling, you can see there, please keep an eye out for suppressed parts, buried parts, features after end of part, adaptive features, adaptive sketches. And why I've got adaptive features sketches over there. If you don't know what you're doing, if you don't really know what adaptive features are, rather stay away from them because they can, give you some very unpredictable results. So unless you really know what you're doing with that, rather stay away from them. Empty sketches, unused sketches, and holes or not hole features. Okay. And then you can even make some eye properties. So, if you're in a design and you say, I have to have a stock code in there, I have to have a description in there, then check the eye properties. Is it there or not? If it's not, then you'll see a little red bar in the gauge, and then you can go fix that because your design is not, not up to standard. Okay. On the machining side of the CAM side, you can see there, you can check for different hole diameters, hole size increments, and even, I think over there it's like inaccessible holes, so that when you take this off to someone who's going to machine this or manufacture this on the CNC machine, that they're not going to have too many issues either because you've actually modeled it up correctly. Okay, so some of you might have heard of iLogic, some of you might not have heard of iLogic. This, it is programming, or it's, if-then statement. So there's a little bit of VB involved on it, but you don't have to use that to help with your design. We've got something in there called iLogic forms. And, this helps when it gets to identifying what the parameters are, the key parameters are, so that you can very quickly and easily change them instead of having to go open up the parameters dialog box and scroll through your 5,000 or 1,000, whatever parameters that you've renamed to get to the correct one. Okay, so it's a very, very nice way to communicate your design, to someone else who's going to be opening up this drawing for them to go and change it to the standard or spec that you wanted to. Okay, how do you create an iLogic form? Very, very quick and easy. So if you see at the top there next to the model, you got the plus button. Click on that, click on iLogic, okay, click on the forms, add a form, and then just on the left-hand side, all the parameters that you got. So identify the key parameters, drag and drop it into your form one, and you'll see there, now you've got it. So you've got your form there, which is now, that was very simple. You don't have to do any work. You just have to create the form. And it's a simple case of drag and drop. One thing you want to do is limit your input options. When you're doing a design that's standard in the company or doesn't, you can't have any sort of rogue agents coming in, make multi-value parameter. So on any of the user parameters or model parameters, you right click, make multi-value, put your different values in, and you can see there I can only choose there 100, 20, 40, and 60. So now what happens is no one can go put in 75, which maybe is not part of your design standard of the company or what the client wants. Okay. In your iLogic form, so this is going to have to dig a little bit deeper, but at the top bottom over there, you'll see the edit control type, and you've got a slider. And that slider allows you to slide between a minimum, a maximum, with also a step value as well. So you don't have to go and create, from what is this, up to 50, so 0, 5, it would be 10 of them. You don't have to go create those 10 values. All you need to do is you just need to create that slider with an incremental step size, and you've created those 10 values and nothing else. You cannot change it, from the form that you've got. It's changed in your original iLogic editor over here. Okay, so there's just basically what it looks like. Okay, to get it, you click on the forms, and now you've got the drop-down arrow. You've only got 100, 20, 40, 60, and at the bottom there, you can see there, okay, it's saying it's 14, so it's not the correct one, but it should say either 0, 5, 10, 15, all the way up to 50. Okay, so in summary, just when you're doing these modelings, before you start, stop and think, make a plan. This is not AutoCAD. This is a parametric package with lots of calculations that you can put in and lots of rules which make sure that your design is on the right track and you get out what you put in. Standardize application settings and your templates. Okay, I didn't really speak about application settings, but go into it and make sure that everyone's application options are the same so that you guys are getting the correct materials. You guys are getting the correct template with the correct size arrowheads, the correct size font, etc. Take charge of relationships. If something goes wrong, fix it. Don't wait until right at the end of the project, because inevitably it happens. Oh, this needs to be changed because there's something, it's an emergency. Because you didn't take charge of relationships early on, it's going to cost you a lot of time later on. Test, test, test. Do not leave any booby traps behind. Okay? Document your design intent. Make sure that either yourself in 3 to 6 months' time, when you do come back to this design nose, can very quickly and easily get into the design and change things and know exactly why you did it, as well as your teammates as well. It's very frustrating if you get a model haphazard and you have to dig through all this sort of garble to be able to just make your designs. And if it is well documented, it should have been an easy 5, 10, or maybe a minute change. And roll back the UAP. Okay, let's look for ways to improve for next time. Okay, roll it back. It's a very, very useful tool, just to be able to look and diagnose designs that are not yours, and to also learn going forward. Okay, great. Thank you very much. That's the end of my presentation. Are there any questions? If you do want to ask a question, if you just click on the under your audio tab, there's a little microphone. Just click on that. If there's a line through it, you're able to ask a question. Hello?
Hello?
Yes.
Yes, and this presentation, will we be able to get a copy of it?
Yes, I will be uploading it to our YouTube channel, and then you can go through it again. Yes.
Okay, great, thanks.
Awesome. Any other questions? Okay, if that is all, guys, have a fantastic Tuesday and a fantastic rest of the week. And yes, thank you very much for attending. Cheers.
Thank you.
Cool. Pleasure.